Hey guys, welcome back to a new Compose Multiplatform video, which is all about deep linking for Android and iOS. And in case you don't know me, I'm Philip, and since 2019, I'm doing nothing else than developing software for the full stack with Kotlin. So if you want to learn more about Kotlin with more than 1,000 videos, then make sure to subscribe to this channel. What we will build in this video is this little Compose Multiplatform app here, where we'll have a list and a detail screen. So if we click on an item, we get to the detail page, we can navigate back. We will use Navigation Compose, so the normal navigation framework for Compose Multiplatform from JetBrains, but we will implement this in a way that we can deep link to the detail screen. A deep link is in the end nothing else than taking a URL, so a normal or a browser-based URL or something where you have a custom scheme maybe, and when a user opens that URL, you want to not lead them to the browser, but instead lead them to a specific screen of your app and extract certain data from that URL. For example, the ID of the item we want to show the detail screen for. And this will look like this. So even though we have no items here, the app is completely closed. If we go to our terminal and we use this adb command here, and I will explain all this in the video itself, just for demonstration here what we'll build, this would be our custom URL that we developed the deep link for. This would, of course, be your URL when you build an app. And if we send this to our phone, then you can see the item with the ID 12 is opened by clicking on this URL here with the item ID 12. And we will build this for both the Android and the iOS side here in a Compose Multiplatform project. And I can also already share great news with you, because I'm in fact working on the biggest app that I've ever made a coding course about. And this app will not just be slightly larger than the largest current app that I've made a course around, but it will be much, much larger. And very soon you will be able to learn building a huge industry scale app with everything that belongs to it. I don't want to share too much yet, but keep following my stuff and you will hear from it. So let's dive into Compose Multiplatform here. And the first thing that I need you to do is to actually set up some dependencies in our version catalog. So here, make sure you are in the project view and then you go to Gradle libs versions toml, because this is where we on the one hand need to define our navigation compose dependency, our navigation framework, where we define which screens we have in our app and from where we can navigate to which other screen, and Kotlin X serialization, which goes hand in hand with it. I will link my GitHub repository down in this video's description, where you can simply copy paste these versions. You will need this JetBrains compose navigation dependency here, and you will need the Kotlin serialization Gradle plugin. After you've added all that, make sure to synchronize with Gradle. A little button will appear, and what comes next, wiring all that together and adding these dependencies to our project, that I will lead you through. First thing, we're going to go to our build.gradle KTS in our root folder. And here, we will duplicate this last alias line, and we want to add the Kotlin serialization Gradle plugin here with apply false, just like all these other plugins. And then we jump into our Compose app module, build.gradle, and then, first of all, also add the Gradle serialization plugin here in the plugins block, kotlin.serialization. And then down here, under source sets common main, this is where we add all of the dependencies that we want to use in our shared code section in our Compose Multiplatform project. And here we will really also duplicate this, because we want to add the Compose navigation library by saying libs JetBrains compose.navigation. And once you've done that, you can click on Synchronize Now, and after that sync, we will be able to use all of those dependencies and start building our deep link setup. So my Gradle sync is now successful. What's the first thing that we want to do? In the end, defining deep links, that's something we need to do for each operating system, for iOS and Android. Defining that needs to happen twice for each platform in the end. And also how deep links are handled differs a little bit from platform to platform. So let's actually start with the Android side. For the Android side, we want to go in Compose app, source, and obviously in Android main, because this is the Android part of our code base. And here we will have this Android manifest XML file, which is kind of a configuration file in which we can configure certain high-level pieces of logic and pieces of configuration properties here for our Android application. And one of these things are these so-called intent filters, because the way deep links work on the Android side is the moment a user clicks a URL, clicks some kind of link, the Android operating system will check if there are any apps that can satisfy that deep link, that match this URL schema. So for example, if you are clicking on an Instagram link in your browser that links to a specific Instagram post, then if the Instagram app is installed, that Instagram app has defined something in its Android manifest file that tells the Android OS, this is a type of link that I, as the Instagram app, can open. And that's exactly what we now also need to do, because the moment a user clicks on this link, the Android OS will send a so-called intent, so kind of an envelope with data to your app if your app says, I can receive this type of intent. And then when your app receives that, you can extract the data from that URL, for example, the ID for that corresponding list item that was clicked on, for the corresponding Instagram post or so. And this works via so-called intent filters, because with these you can define which certain types of intents your app can satisfy and your app can be opened with. So we want to now define this here, a new intent filter. And here we can now define exactly that. On the one hand, the action that is a part of every intent, and in the end just says, hey, this is a high-level thing that I want to do with this intent. That is my intention. And here for deep links, this is typically just Android intent action view, because a user wants to view a certain content piece, like a detail screen or whatever you want to show in that detail screen. Next up, you can define certain categories. So here we will, on the one hand, define Android name default. This will make your app appear as the default option for these types of deep links. So normally when multiple apps can actually satisfy opening this link, then Android will display a little chooser where the user can say, hey, this app should open it. And this will allow us to also show this as a default, so our app will open as a default option for that. We want to define another category, which will be the category browsable. This will make sure that your deep link can be opened from a browser. So when a user really clicks on a link in your browser, then this can be satisfied that way. And lastly, we want to define certain data tags, because this really now defines the URL schema that we want our deep link to satisfy, or our app to receive here from URLs. On the one hand, the scheme, so what is typically HTTPS, but you can also define your own custom schemes. So we will make sure we will use HTTPS here, but then also have another data tag for the host. So that is the real domain. So I will just choose my-url.com here. This will, of course, be your real URL that you want your app to open. And lastly, we will have an actual path prefix, so what comes after HTTPS my URL. And here we can then define the actual path pattern we expect in the URL, for example, /item/. And this pattern here would now satisfy URLs in the format of this, so HTTPS myurl.com/item and then some kind of ID. If a user just clicks on this here, then our data tags here won't match that, because we say we require this item relative part of the URL. You will also see that we get a warning here on the intent filter. It wants us to set this auto verify attribute to true here, which we do want to set, because in fact, if you use deep links or you want to deep link into your app with a normal HTTPS link from a browser, then Android won't just allow that by default. iOS also won't, because Google Play and the Apple App Store wants to verify that you really own this URL here before allowing to deep link into your app via HTTPS. This verification is quite hard to show for a video, but it's just important for me to mention that will happen with the Google Play console after all, and you will have to add a file, a certain file that Google gives you, to a specific path of your URL and make it accessible so that Google can see, okay, you really own the server and you can put their file on your URL. What you can always do without verification are custom schemes. So what we can also do is copy paste this intent filter. We remove this auto verify and leave all the rest here unchanged, except for the scheme, which you can choose anything for. So you could literally say poop here, and then this will match URLs with the format poop_myurl.com. This now doesn't require verification because, well, URLs with this scheme won't really show up randomly on the internet. But if a user really opens such a link with your custom scheme, then Google is pretty sure that this is also your link. This is on the one hand how we define these deep links for Android, so that our app can at least receive these, and that our app will appear as an app that can satisfy links with a certain pattern. This won't yet really let us extract this data, so ID here that comes afterwards. So let's build that next by going to Kotlin, actually not in Android main, but in common main, Kotlin, and here I will create a navigation package in which we'll define our nav host, so the primary entry point for navigation. Let's call this nav root, this new composable, make this a file, composable, nav root. We can remove this modifier here. And in here we will create our nav controller. This is the primary unit to control our navigation with, to say, hey, now navigate to another screen. And with this nav controller, we can then connect this with a nav host composable. Here assigning this nav controller. And that's now also the time where we need to define which routes we have in our app, so which screens we can actually navigate to. Let's put this in a separate file called route. This can be a sealed interface in which we can say we have, for example, a data object called list for our list screen. This list screen doesn't come with any arguments. That is why it's a data object. And then we may have our detail screen, which can now be a data class because it takes an argument, specifically the ID that we clicked on or that we want to deep link to, and also make this a route. And since Compose navigation works with Kotlin serialization, we need to annotate these with serializable, so these routes can be serialized and we in the end have a type-safe navigation setup. Doing the same here. And then with this information, we can go back to our nav route, define a start destination, and we set this to route.list, because that will be the first screen that will open up when we open our app. In here, we can then define our two screens with composable. We say this will now define how our list screen looks like. And we will have the same for our route.detail screen. Let's quickly build some sample items here in the list screen that we can click on. So we make this a lazy column, display a bunch of items, modifier fill max size, and we maybe give this some content padding of padding values 16 dp. In here, in this lazy column, we can then say we have, let's say, 100 items that we hardcode here, and each item is nothing else than a text that says item and whatever item count that is. And we give this a modifier, so we make this a clickable modifier, fill max width first of all. We then say clickable. And when we click on this specific item, something, we want to just navigate with our nav controller to our detail screen, route.detail. And well, the ID we clicked on is in this case just our index of this item. So we can also pass it here. And lastly, we give this some padding so the items aren't that cramped. And this would already be our list screen. For the detail screen, we could really just have a box with a centered text that says which item we clicked on. So we have a box with a modifier, fill max size, and we say content alignment.center. And then inside that box, we can say we have a text composable that simply displays the specific item we clicked on. Well, how do we now extract this specific ID we clicked on? How do we get this information here? In the end, what Compose navigation gives us here is a so-called nav backstack entry, and that contains all the information about the current destination we are navigating to, for example, also the arguments. So we can get the backstack entry here, and then we extract the route from this backstack entry, that to route, and we define what type of route this is, in our case, our route.detail. And this is now really just an instance here of our data class where we can then safely extract the ID out of. So here we can say route ID. And this will already make normal navigation work since we define this here, but it won't yet make deep linking to this detail screen work. In order to support that, what we need to do is we need to go in here and we define a deep links list. So a list of nav deep links in which we can configure the specific path pattern for which we want our app to deep link into this route detail screen. And that simply works by saying this.URI pattern. And here we define the entire URI pattern that we want this deep link to support. And that is https my-url.com item. And then here for Compose navigation specifically, we have curly braces. And here we include the actual parameter, our ID, that is also part of the deep link, so that Compose navigation knows, okay, whatever comes in here, I will substitute for the argument with the same name in our route definition. So this is important that this ID here has the same name and spelling than this ID, as this ID parameter here of the detail screen. If this is the case, then Compose navigation will automatically connect these two. Then here we want to also define another instance of a nav deep link, because we want our app to not only support HTTPS deep links, but also poop ones. And for either of these, our app will then trigger. And the moment our Android app receives an intent that matches one of these filters here at least, this intent will make sure that Compose navigation will automatically route to our detail screen. And this is also something we should already be able to test for the Android side by taking this nav route composable and adding it here to our entry point, our app composable. By removing all that, for iOS it won't yet work. And in here we now want to put in our nav root. And this I will now run on my device that I will open here, because at this point it should look really similar to the app that I've showcased here in the beginning. There we go, the app is open on my Android device, and if we now click on item 6, for example, we get to our item 6 screen, and we can again navigate back. If we now close the app, and we want to simulate this deep link, because I don't have a URL ready at this point, so we need a way to simulate that, then we will use exactly what I also showed you previously here. We'll go in our terminal, and we will use this ADB command. ADB is the Android debug bridge that will allow us to send certain commands directly to our Android device. So we will type this command, ADB shell am start dash capital W and A. Then we want to define the action here with this dash A tag, which is Android intent action view. So the same action that we've specified in our Android manifest. Then we want to define the domain with a dash D, which in our case is poop myurl.com, an item, and then we type a certain ID for the item that we want to open. Lastly, we want to define the package name that we want to send this intent to. And here we really want to use our package name, so whatever is here for you after package. Copy that, paste it in here, and if we now hit enter, then our app opens with the item 16. And I think in the terminal this should also work with HTTPS. So if maybe we don't even need to close our app, this will also work like that. If we actually use the same command again, but this time we define HTTPS and we define some kind of other item, 19, hit enter, then you can see our app will receive it and navigate to item 19. So on the Android side, we already have a fully working setup for this. How do we now make this work on the iOS side? Making this work for iOS is actually a little bit trickier, and it requires some helper classes. But before we get to those helper classes, let's take a look at how deep linking in iOS actually works natively. And for that, we want to open our project in Xcode by going to File, Open Project in Xcode, and then we will take a look at the native iOS part here and how deep linking really works over there. So here I am, I've opened the app in Xcode, and this is really just the iOS app part. Here, we want to go into the info plist file. This is now kind of the iOS equivalent of the Android manifest. And here we want to define our custom scheme, because that is the only thing we need to define for deep linking on iOS. In case we have a custom scheme, then it must be defined in here. So let's go to this information property list, click on this plus, and here we want to type URL types, hit enter. Then you will see this new item that you can open here, item 0. You can also open this. And here on this item 0, we want to also hit this plus, and then add URL schemes. Hit enter, and then for URL schemes, we open this again. And this item 0 here for the right value, we want to type, because that is our custom scheme. That's how we define this here on the iOS side. Now on iOS, we don't really have this concept of intent filters like we have it on Android. It's in the end a different platform, a different operating system, so different rules. So how do we receive these specific URLs on iOS? We do receive these by going to our iOS app Swift class. And here where we have this content view, this is in the end the UI entry point for our iOS specific site. And here we can say that on open URL, which will give us a lambda, where we get a URL in. So this is really just giving this parameter from this lambda a name. And this is now the callback lambda that iOS will call when our app gets opened with a specific URL. Now, when thinking about it, we should actually also add our URL host here to the info file by going to this item 0 here and also adding a URL identifier. This is our host. And here, this is already present. Okay. I'll click cancel here and remove this again, replace. So just make sure that you have one instance of this URL identifier here. And then here you can specify the URL pattern. So in our case, this would be myurl.com. And if you have custom schemes, then put these here. But now in the end, what we need is, we need a way to let this callback trigger, well, this will already trigger with a specific URL that we've opened that matches our info plist URL scheme. But we now need to take this URL and we somehow need to tell our compose navigation library that this URL was opened to really navigate into the right screen. And for that, we need to go back to Android Studio. Because what we will need here is something that we will call an external URI handler, so kind of a bridge between our iOS side and the KMP side. Here in navigation, we want to create this external URI handler, and we make this an object, so Kotlin singleton. We will define a private var cached, which is a nullable string this will be a URL here that we save. And I will really explain how this works after having typed this, because I think before it confuses you more than it helps you. Because next up, I want to have a listener, which will be a nullable listener that gives us a URI of type string. So a URL that we clicked on. This is nullable. And we also set this to null initially, but then we override the setter of this. So we want to set a certain new value. So whenever we assign a new value to this var field, then the setter will be invoked. And in the setter, we on the one hand want to set the current field's value to the new value. That is the default setter after all. But we also want to check if the new value is not null. And in that case, use our cached URL, have another null check, and we invoke our new value with it. So value invoke with the new, or with a cached URL. And then we set cached back to null. And now the last missing piece here, before I really explain what happens here, because this looks quite complex, I know. The last missing piece is a function on new URI, where we pass in a URI of type string. Here we will set cached to our URI, and we will then say listener question mark let. So we check if this listener exists, we make a null check. If so, we invoke it with our new URI, and we set cached to null. So what happens here? The thing is, we in the end now need a way to let our Swift side, this specific callback here, make a function call of our Kotlin multiplatform side. This will happen via this external URI handler. So the moment a URL really arrives in this Swift callback, we will trigger this onNewURI function here from this external URI handler with the URL that was triggered on the iOS side. We cache this URL here in memory in this class, in this object. And if we've already registered a listener that should be notified the moment the deep link should be handled on the iOS side, then we invoke this listener. So we simply call this Lambda function and we set the cached value back to null. Now this cached value is just necessary here because it could be that the iOS app is completely closed, then gets a deep link delivered to it, or then an URL is opened on the iOS side before this listener even had a chance to properly set up, because this will in fact be initialized from our Compose UI. And it could be that our Compose UI isn't yet fully composed, isn't yet fully initialized, and still a deep link is already arriving on the iOS side. In that case, what will happen is the onNewURI function will still trigger. It will cache this deep link. And the moment we set the first value here of this listener, the moment we say in our Compose UI, now you're initialized, here, next thing, initialize this deep link listener. In that case, check, once this has been initialized, is there a cached deep link URL? And if so, then immediately invoke the listener right after initializing it with that cached URL and set it back to null, because then it's handled. This is the official solution here from JetBrains. I know it feels a little bit hacky, but this is how this works after all for platforms that aren't Android. So the last step is really to use this listener and assign it in our Compose UI. And whenever this listener triggers with a new URI, then we want to navigate to that URI in Compose Navigation. And for that, we go to Navigation, create a deep link listener, which we make a file, a composable deep link listener. And all this deep link listener will need is our nav controller instance, because in here, we will create a disposable effect with unit, so with a constant key. And the moment this triggers, we use our external URI handler and we set the listener to a new lambda where we get this URI. And this block of code will now trigger when we receive such a URI, such a URL on the iOS side, and we call this onNewURI function from there. And now we can decide what we want to do the moment we are about to open a deep link. And well, we of course want to perform a navigation. And that works by saying nav controller, navigate, and we want to navigate to a nav URI, where we can pass in this URI string. Lastly, we want to make sure to properly clean up things when the Compose UI isn't needed anymore, where we use this composable in. That works with onDispose here, so this block will be called as soon as this disposable effect leaves our composition. So the screen that it's being used in is not there anymore, is not being used in Compose. In that case, we simply want to reset this listener so we don't leave this around for nothing. And this is now what we call in our nav root here, after having initialized the nav controller, we say deep link listener and we pass in our nav controller instance. And now the last thing we need to do is we need to invoke this onNewURI function from the iOS side. And since on the Swift side, here in content view, you can see we can perfectly import stuff from our Kotlin multiplatform project here, our Compose app module. We can also do this in iOS app, import Compose app. Very often it will show this here as no such module. This is typically resolved after rebuilding this project. So if we now launch this here on our iPhone simulator, this won't work yet. We still need to type our code here, but this should already help to get the code completion here. So now you can see the app has been successfully launched here on iOS, which also shows the module must be resolved. Here we can also click on these items and navigate, but the deep linking won't yet work. I just launched this in order to get the code completion. Hopefully, sometimes this is still bugged. But if we now go in here and we type external URI, and you can see we still don't get this code completion. But we can still type what Compose or what Swift here would expect. And that is, okay, now it actually noticed that, because this shared attribute, this is what we get when referencing a singleton, a Kotlin singleton from Swift. Then we want to reference the shared instance. That is in the end the only single instance of this object. And then we can say on new URI, perfect, now it's resolved. And here we just pass this URL, so the absolute string of that, by saying URL.absolute string. If we now launch this once more and take a look on our simulator once that's launched, there we go. Let's actually make sure to close our app with Command, Shift, and then double tapping on H. Then we can close this here so that we see that this really works in a kind of a cold boot setting. Because what we now want to do on the iOS side to simulate that is something very similar to what we did on Android, just with the iOS dev tools. So I've opened my terminal here, and the iOS dev tools are called xcode run, so xc run. We want to call symctl, open a URL, we call booted, and what follows next is actually the URL that we now want to simulate a click on to deep link into our iOS app. And this will be myurl.com/item, and here we specify maybe 15 as the ID. Of course, must be something below 100, otherwise this won't work. Well, I think otherwise this should work, because we haven't really linked our item from the detail screen with the list screen. But if we now hit enter, we see on our simulator, open in CMP deep linking. And yes, we want to open it there. We click on open, and our item 15 is opening. So cool. Let's also try this with the HTTPS link. So the iOS simulator on my end here is super bugged. I can't navigate back. So I always have to close this. And I'll also uninstall my other app to be super safe that it's not deep linking to that one. Delete app, yes. And then we will try this once more here with an HTTPS link by saying HTTPS my URL and then hitting enter. Now it's opening here. Okay, and that doesn't work because you need to verify this apparently on iOS before. So similarly as for Google Play, you would also have to properly verify your URL there when really deploying your app to the Apple App Store. And if you actually want to stay up to date with the biggest app that I've ever made a course about, then down in this video's description, you will find a WhatsApp broadcast channel for Kotlin Multiplatform. In this broadcast channel, I regularly share tips about Kotlin, Compose Multiplatform, and updates about this course. So join there now, and maybe you're also among those who get access to a very, very good deal. Thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.